An if-then statement is written in the form of if P then Q, and the phrase immediately following the word if is the hypothesis. And the phrase following then is the conclusion. So the statement goes, if P, then Q. So it would be if two angles have the same measure, then they are congruent. So the P in that statement would be two angles have the same measure, and the Q would be they are congruent. In a converse statement, the order is Q then P. So you would write if two angles are congruent, then they have the same measure. So the Q was if two angles are congruent, then they have the same measure. Then there's an inverse statement. And that goes not P, then not Q. An example of that would be if two angles do not have the same measure. Then they are not congruent. So the not P is two angles do not have the same measure, and the not Q is they're not congruent. And the last one is contrapositive. The order of that is not Q, then not P. An example of that is if two angles are not congruent. Then they do not have the same measure. So the not Q is two angles are not congruent. And the not P is they do not have the same measure. True, both the P and the not Q in this example has to be true. And the not Q that has to be the opposite of this, and this one would be false. This one is true, false, and true. So in this statement, it's P and not Q. So since only one of them is true, the statement is false. In this one, P and not Q are both true, so the statement is true. And in this one, they're both false, so it's false. And then in this one, there's only one true, so that one is false. So that would be your answer for that example. Or statement, only one of them has to be true. So first we have to find the not Q to be the opposite of the Q. False, true, false, true. So to find this, you have to do the P or the not Q. And since one of them is true, the statement is true. In this one, they're both true, so it's true. This one, they're both false, so that would be a false statement. And this one, there's one true, so it would be a true.
Deductive reasoning is a system of reasoning that uses facts, rules, definitions, or properties to reach logical conclusions. For law of detachment, you have if P is equal to Q, and if that's a true conditional statement, and P is true, then Q is also true. And then we have law of syllogism. And that is if P then Q is a true conditional statement, and Q then R is also a conditional statement, then P is equal to R is also true. And another way to look at that is if, like for instance, you have 1 equals 2 and 2 equals 3, then 1 also equals 3. Okay, for 2.1 postulate, it says through any 2 points there is exactly 1 line. So for example, we have 2 points here, and those 2 points have 1 line going completely through them, both. And then for 2.2 it says through any 3 points not on the same line, there is exactly 1 plane. So say for instance we have these 2 points are on the same line, but then we have this point right here, which does not go on this line. You would have 1 plane that holds all 3 of those. And then for 2.3 it says a line contains at least 2 points. So to make up a line, you have to at least have 2 points to complete it. For instance, like that one. And then for 2.4 it says a plane contains at least 3 points not on the same line. So just like 2.2, we have 3 points. But for instance, these 2 are on the same line, but this one isn't, so you have 1 plane. And then for 2.5 says if 2 points lie on the plane, then the entire line containing those points lies in that plane. So we have a plane, and there's 2 points here, but the line goes out of it. No matter what, the line is still on the whole plane because the 2 points is on it. And then for 2.6, it says if 2 lines intersect, then their intersection is exactly at 1 point. So we have this line, and we have this line. And right exactly where they intersect, you would have a point. For 2.7, it says if 2 planes intersect, then their intersection is a line. So for instance, we have this plane here, and we have another plane that's going to intersect it like this. This this would be the bottom of the plane, but this is where it intersects. So this would be the intersection line of the two planes.
Okay, first is the reflexive property, and it's for every number A equals A. And then there's the symmetric property, and for all numbers A and B, if A equals B, then B equals A. And then the transitive property for all numbers A, B, and C, if A equals B and B equals C, that means A equals C. And the addition and subtraction property for all numbers A, B, and C, if A equals B, then A plus C equals B plus C, and A minus C equals B minus C. And then the multiplication and division property for all numbers A, B, and C, if A equals B, then A times C equals B times C. And then the substitution property for all numbers A and B, if A equals B, then it can be replaced, A can be replaced by B. And then the last one is the distributive property for all numbers A, B, and C, if A times B plus C, that means it's A times B plus A times C. And how should I do this one? Should I do
For postulate 2.9, it says, it's the segment addition postulate. It says if B is between A and C, then AB plus BC equals AC. And here we have the example, you have the segment A, B, and then BC, and the whole thing equals AC. And then theorem 2.2, you have a flexive property, so segment AB would equal segment AB. Symmetric property, you would have if segment AB is congruent to segment CD, then segment CD is congruent to AB. And transitive property says if segment AB is congruent to segment CD, and segment CD is congruent to segment EF, then segment AB is congruent to EF. For this proof, we have a drawing over here, and we are given that segment JK is congruent to segment KL, and that segment KL is congruent to HJ, and that segment HJ is congruent to segment GH, and we have to prove that segment GH is congruent to segment JK. So in proofs, you always write the given known first, so you just copy it over. And then for the second one, we have JK is congruent to HJ by the transitive property. And that's because they are equal. For 3, we have segment HJ is congruent to segment GH by also the given. For 4, we have segment JK is congruent to segment GH by the transitive property. And then for 5, we find the answer. That segment GH is congruent to JK by the symmetric property.
Okay, the angle addition postulate says if R is the interior of angle PQS, then the measure of angle PQR plus measure of angle RQS equals PQS. The supplement theorem says if two angles form a linear pair, then they are supplementary angles. An example of that would be if you have angle 1 here and angle 2 here, angle 1 plus angle 2 equals 180 degrees. The complement theorem is if the non-common sides of two adjacent angles form a right angle, then they are complementary angles. And an example of that is angle 1 and angle 2, and if you add angle 1 plus angle 2, that equals 90 degrees. The reflexive property is angle 1 equals angle 1. The symmetric, if angle 1 equals angle 2, then angle 2 equals angle 1. And the transitive property, if angle 1 equals angle 2 and angle 2 equals angle 3, then angle 1 equals angle 3.
Okay, theorem 2.6 is angles supplementary to the same angle or to equal angles are congruent. Theorem 2.7 says angles complementary to the same angle or to equal angles are congruent. And then 2.8, the vertical angles theorem. If two angles are vertical angles, they are equal. So 1 and 3 are vertical angles, so they're equal, and 2 and 4 are vertical angles, so they're equal. 2.9 is perpendicular lines intersect to form two right angles. 2.10 is all right angles are equal. 2.11 is perpendicular lines form congruent adjacent angles. 2.2, if two angles are equal and supplementary, then each angle is a right angle. And 2.13, if congruent angles form a linear pair, then they are right